Hello everyone, welcome back to my channel The Social Pie. I am Ayan Khan and today in this video we are going to prove one of the most basic rule of calculus, that is power rule. Okay, so let's start the video. Okay, so first let us see the definition of derivative. Okay, so let's say that we have a function f of x. Okay, so the derivative of this function f prime of x, this will be f of x plus delta x, the change in x, minus f of x all over delta x. But we have a limit here, limit as delta x tends to 0. Okay, so this is the definition of derivative. Now we will use this to just prove the power rule. So let's say that we have a variable, let's say that we have f of x equals to x to the power of n for any positive n. Okay, n is a positive integer. Now so if we find f prime of x, this is equals to limit as delta x tends to 0. Okay, now f of x plus delta x, so this will be x to the power x plus delta x to the power of n minus delta x, put this in parenthesis, delta x upon, actually this is x, just this is just x upon delta x, because it was asking for f of x. Okay, so this is just x upon delta x. Now using the binomial theorem we will expand this. Okay, so this is x to the n first, then plus n choose 1 times x to the n minus 1 into delta x. This is the first part, I mean second part. Okay, then plus n choose 2 x to the power of n minus 2 like this times delta x square plus so on so on. Now we still have minus x to the n because it's f of x, so minus x to the n, so this is minus x to the n here. Okay, at the last. Now this is all upon delta x, so we make it a vulgar fraction. Okay, now what will happen here is that x to the n and negative x to the n both cancels out. Okay, and we have delta x in all of it, right? Delta x here, delta x square here, and in the other parts also delta x cube, delta x to the power of 4. Okay, so we can just factor them out. So we get, let me just write it quickly, delta x into n choose 1 x to the n minus 1. Now we don't have any delta x here, plus n choose 2, actually it's n choose 2 x to the n minus 2 delta x, only delta x because we have taken 1, so this is x, so on like this all over delta x. Okay, now this will both cancel out, delta x and delta x cancels out. So since the limit was going to 0, right, delta x was going to 0 and we don't have any delta x in the denominator, we can just plug in 0, right? If you plug in 0 except this element here, except this part, all of it will go to 0, will become 0 because they have delta x, and 0 multiplied by anything is just 0. So this all will go 0. We are only left with n choose 1 x to the power of n minus 1. Now this is n choose 1 x to the power of n minus 1. Now for solving this we know that the formula is n choose k, right? This is notation, this is n factorial upon k factorial into n minus k factorial, right? So this will be, here we have n factorial This is 1 factorial, so this is 1 factorial into n minus k, n minus 1 factorial, like this. And we still have x to the n minus 1 here. Now this becomes n factorial upon n minus 1 factorial into x to the power n minus 1. Now see this, we have n factorial and we have n minus 1 factorial. If we see this, this is n into n minus 1 into n minus 2, so on until 2 into 3 into 1, right? And in the denominator we have n minus 1 factorial, so this will be n minus 1 into n minus 2, so on until 2 into 3 into 1, right? So everything except the n will cancel out in the numerator and denominator, right? We get n here at last, right? So this will be n into x to the power of n minus 1, and this is our solution. This is the our rule, right? So guys, thanks for watching this video. Please subscribe, like, share and comment. Thank you.